Chapter 1. We are continuing on with our data chapter. And in this video, we're going to be talking about describing quantitative data. And this will be the first part of 3 parts. So in our previous video, we talked about categorical data. And in this video, we're going to talk about quantitative data. Quantitative data is a variable that takes numerical values for which it makes sense to calculate an average. With our categorical data, many of our variables were things that had words and really wouldn't make sense to calculate an average for. But it didn't necessarily mean that categorical data was always non-numerical values. We talked about in video 1 that area codes, for instance, or zip codes could be categorical variables. It wouldn't make sense to calculate the average area code of 5 people. But all of these variables that I have listed here, it would make sense to calculate an average of. The average number of hours slept for a person, the average age of a group of people, the average number of calories consumed in a day. And in the last video, I had Likert scale on there. But I also have Likert scale in this video. So in the categorical sense, a Likert scale could be something that says, on a scale of strongly disagree to strongly agree, what would be your opinion on this particular topic? There are Likert scales where they are based on a numerical scale. So it might say on a scale of 1 to 10, where 1 is least favorable and 10 is most favorable, what would be your opinion on this topic? And so then it would make sense to actually calculate an average favorability of a Likert scale model. The distribution of a variable is the values a variable takes and how often it takes those values. So for instance, if we were going back and talking about one of these particular quantitative variables, we might pick on, let's say, age, for instance. And if we were talking about age of high school students, well, we could have the values the variable could take. We could have 14-year-olds. We could even have 13-year-olds maybe in high school still. 13, 14, 15, 16, 17, 18, 19. We could even get above and beyond to some super seniors and some super duper seniors until they're 21, and then technically they can't be in high school anymore. So let's say the ages of high school students could be anywhere between 13 and 21, and then how often it takes those values. Well, then we could count up, well, how many 13-year-olds do we have in high school? How many 18-year-olds? How many 21-year-olds? And so that would be our distribution of our age variable. Now, we will describe the distribution. Notice how I'm coloring this in a different color than everything else in here. This will be a really important concept and a theme that we will hit really hard this chapter, and it'll be present really throughout the rest of the year. So anytime we are asked to describe the distribution, we're always talking about a quantitative set of data, and we're going to describe it in 4 special ways. And in this video too, we're going to focus on 2 of those 4 special ways. Now, I use an acronym called SOX, and it's a pretty common acronym with many statistics courses. And we're actually going to start on the tail end of SOX. We're going to talk about the first S and the O here in the next video. And we're going to talk about really the common things that you guys would probably know more about than anything. So first we're going to start with C of SOX, the center of the distribution. Now, the center of a distribution is what we have typically called the average our whole lives. And typically, the mean is what we would call the average. But technically, mean, median, and mode are all measures of center. They're all averages, if you will. Though typically, I would say 90+% of the time, when we say the average, we really mean the mean. Now, the mean, just in case you guys have forgotten what the mean is when you take the sum of all the values of your data set and you divide by the number of values in that data set. So nothing new here, something you've done probably most of your mathematical life. The median, which again is something that I'm sure is not new to you, it's the middle value when the data is arranged in order from least to greatest or greatest to least. Doesn't matter which way it's arranged as long as it is in some sort of order. Now, what happens if there's a tie? If there really isn't a true middle value? Well, then you just take the mean of the 2 numbers that are tying for the median. And then that number is technically the median. The mode is the most frequent value in the data set. Now, unlike median, if there are two numbers that are the most frequent values in the data set, then you just list what those two values are. And sometimes it's possible that you could have three or more values that are the most frequent value in a data set. And again, you would just list all of those. So out of the three common measures of center, we're really going to focus our attention on mean and median. More on mean, less on median, and very, very rarely will we ever refer to the mode of a data set. But it will be important when we get into the next video, when we get to the shape, the first S.
The last S of SOC stands for spread, and that's really going to tell us how much variability or how spread out our data is. So there are three typical or common measures of spread that will be used to describe the distribution of the data set. And so range, we're going to start with probably the most common thing. And range was simply just the maximum minus minimum values. The range is always positive, and it's always true that the spread value, regardless of which one you use here, will always be a positive value. So you'll never do minimum minus maximum. It's always maximum minus minimum. And so the range covers all 100% of your data set. Tells you how wide that data set really is. The IQR stands for the interquartile range. So IQR. And the interquartile range is kind of similar to our range over here, except we're not going to go full on 100% of our data max minus min. We're going to narrow it down a little bit. So really the proper definition of the IQR, the interquartile range, is that it covers the middle 50% of our data set. All right, so we get through the first 25% of our data set, then we start the middle 50%, we go all the way up into the 75% of our data, and then we chop off the last 25%. So basically from the 25th to the 75th percentile, or the first 25 to 75% of our data, that difference, just like we did in range max minus min, this is the third quartile, or what will be referred to as the 75th percentile, and the first quartile, which means we have the first quarter or first 25% of our data. Now, Q3 and Q1 will easily be gotten from our calculators, and we'll learn how to get those numbers very soon. So again, IQR, third minus first quartile, Q3 minus Q1, we're covering just the middle 50% of our data set. And then standard deviation. This one's the most complex, and here's the good news. You will not have to calculate the standard deviation by hand, because here's the formula. And standard deviation is typically going to be represented by S sub x in our calculator, and it's the square root of the summation of the first data value all the way up to the last data value, the nth value. So that's what this x sub I represents. This just means every individual data value. And if we subtract away every individual value from the mean, that's what x bar represented here. So if we took that difference and squared it, and then added up all those differences, and then divided by the number of terms in our data set minus 1, and then square rooted all of that, that would represent the standard deviation. Now the definition I'm going to want you to know is it is the average amount that each value differs from the mean. So let's kind of walk through this a little here. And I'm going to start with the second line. Each value, and I mentioned where that part was, this x sub I. So each value that differs from the mean, so if it differs, we're going to be subtracting. And if it differs from the mean, I said mean was x bar. So really, when we say each value differs from the mean, that gets us this quantity here. Now, here's what's going to feel a little weird is the average amount part. Because you guys are used to saying the average is either the mean or the median, and the average is kind of like adding up all our values and dividing by our total number of values. Except we're doing average in a weird way here. All right. If we simply took all of these differences that are right here, what we would find out is when we add them all up, and that's what the summation in the front tells us to do. This means to add up, or here, I'll put this in a different color. We're going to add up all of these differences. So for right now, if I ignored this square aspect, if I were to add up all of these differences, I would always get 0. And if I add up all these differences, and I'm always going to get 0, then the average of something that adds up to be 0 is going to be 0. And that's not really going to help us out here to accurately describe the standard deviation. So in order to bypass the fact that all of the individual values differing from the mean is always 0, then what we're going to do is square all of those differences. So here's the thing. Some of our differences are going to be positive. Some of our differences are going to be negative. And all those positives and all those negatives cancel each other out. And that's why we always get 0. So if we square all those differences, now all of those negative differences are now positive differences. So now when we square all those differences, we have positive numbers. And so we're going to add them all up. And now we're going to divide by, and what seems weird is we're going to divide by not all of the numbers in the data set, but all of the numbers in the data set minus 1. So you're just going to have to go with me for right now. So it's almost like we're taking an average here, but we're taking the average of squared differences. And so now to be able to undo that squared average difference, we're going to do the opposite of squaring in the end, and we're going to square root. So when we say average, it's not like your typical average. So it's kind of like we're saying, quote here, the average amount, when really we're taking the average of the squared differences. And it's not quite truly your average where you would divide by n, but we're going to divide by n minus 1. Okay? Now, again, you will not need to calculate standard deviation by hand. We will do that in our calculator. The main thing you need to know about standard deviation is really this definition, that it's the average amount that each value, and again, each value in our data set differs from the mean.
So I just want to show you something. Why center alone is deceiving. Most people would think, well, if I know the average of a set of data, well, that should give me all the information I truly need to know about it. And what I want to show you is this. Here are 6 films from 2017 that have an IMDb average user rating of 5.2. So all 6 of these movies have an average, a mean of 5.2. But do they all look alike? And so these are histograms in here. And we'll get more in depth on what histograms are and how to create them. But I'm sure you've seen histograms or seen graphs like this before. But if we notice the first 5 films here, they all kind of look the same. And the center, the average of 5.2, is kind of right in the middle of these first 5 movies. And so we would say, yeah, that's typically where we would find most of our data. That's the average. We can see right around here between 5 and 6 is, yeah, that's where a lot of people ranked these 5 movies. But if we look at 5.2 in this last movie, 5.2 is right in between here between 5 and 6, and there really weren't a whole lot of people that gave this thing a 5 or a 6. There was really a lot of, on the other end here, we had lots of people that gave this movie a 1. We had lots of people give this movie a 10. But guess what happens when you average a 1 with a 10? You end up somewhere more in the middle here. So notice that the spread, right, even though all 6 of these movies have the same mean of 5.2, they certainly don't have the same spread. They don't have the same variability or variation. And I would argue that this particular movie, and we'll get more in depth on how you can know how big or small a standard deviation is, but this last movie has the largest standard deviation of them all. Because again, the definition of a standard deviation was the average amount that each of your values differ from the mean. And if we have most of our values on the extreme ends here, and the mean is 5.2, we got a lot of values that differ from 5.2. And so if we take the average of all of these differences between the 1s and 5.2 and the 10s and 5.2, that's going to make the standard deviation larger and larger. So towards the end here, I'm going to show you guys how you can calculate all of 5 of these things. Now, range and IQR, we actually had formulas for. Range was max minus min. IQR, we said, was the third quartile minus the first quartile. But I'm going to show you how you can get the values that you need to calculate range and IQR from your calculator. All right. So notice I don't have a spot here for mode because, again, we're not really going to use mode a whole lot. So here I've got an 84 plus emulator, and we're going to use it to help us calculate the mean, the median, the standard deviation, the range, and the IQR. So first thing I want to do, here I just have a detached screen here, so let me turn on my virtual calculator, maybe. Oh, no, got to press on, not clear. There we go. So we're going to input these 20 Chapter 1 AP Stat scores into our calculator. And if you wanted to calculate the mean, all you'd have to do is add up all these 20 numbers, divide by 20, and there's the mean. The median, you'd have to line all these up from least to greatest or greatest to least and find the middle number. But I'm just going to show you how we can have the calculator find all of this stuff for us. So if you press the Stat button, and then we're going to select Edit, this first choice here. And notice I've got lists, L1, L2, L3, and there are other lists down the line here. There's L4, there's L5, and L6. But I'm going to go back to list 1. And hopefully your list 1 is clear. And if you have values in list 1, let me just put in a few numbers in here, then what you can do to clear it out is go all the way up to L1 where it's highlighted and press clear. Do not press delete. Press clear and then press enter. And that'll flush out all the values in your list 1 or whatever list that you have values in. All right, so I'm going to go ahead and enter in these values. So I'm going to start with the 91. I'm going to work my way down. There's 95, score of 61, a score of 90. There's 78, 65. Ooh, and notice there's a common thing. My 65 really turned into a 6. So there's my 76. There's a 73, 100, 54, 81, 85, 88, 71, 74, 70, 84, 66, 96, and 98. And there's the 20th entry. And I said there were 20 numbers. All right, so once you have all your values in there, then what you can do is you can go to the Stat button again and go over to the Calc menu, and we're going to select the first option here, 1 var stats, or 1 variable statistics. And it's going to ask for a list, and by default it's list 1. But let's say you put your numbers into list 2. How do you get list 2? Well, there's a shortcut here. If you look above 1, 2, 3, 4, 5, and 6 on your keypad, you'll see a blue L1, a blue L2, all the way to a blue L6. And so let's say I had my numbers in list 2. Well, then I can just press second and 2, and that's the shortcut for list 2. So since my list was really list 1, I'm going to go back and do second 1 to get list 1. Frequency list, we're going to leave that alone. Just leave it blank. If there's something in there, clear it out, delete it out. And then we're just going to go to calculate. Now, the first thing that's listed here, this X bar. X bar is really our mean. It's another way of expressing the mean. So notice in your notes here, I've got mean with parentheses written down. And in the parentheses, this is where we get to symbolize what the mean is. So I'm going to write in X bar. And that's how you literally say it, is X bars. There's just a horizontal bar above an X. And that value is 79.8. Now, the median. Well, is there not a fancy little symbol here for median? And no, not really. And if you notice the rest of this, there's nothing in there that would really make me think, oh, well, the median's somewhere in here. So what I want you to do, if you notice there's this little down arrow right here, if you press the down arrow pad on your calculator, it'll show you some more information. And MED is the median, and it's 79.5. So let me write down here. 79.5 is the median. And really, you could use a capital M to signify the median, but typically you're just going to write out the word median. or you could even do MED if you really wanted to, but I would either do a capital M or just write out the word median. So notice my two measures of center, my averages, are really, really close to each other. And there will be some significance behind that we'll discuss later on in this chapter. All right, measures of spread. Let's go back to our screen here. And measures of spread, we need a standard deviation, a range, and an IQR. And I tell you what, since we're already down here on the bottom of one variable statistics, and I can see a min and a max number here, then let's go ahead and talk about range. The max score was 100 and the minimum score was 54, so the range is just the difference of those two. So 100 minus 54 means we have a range of 46 values between the least and the greatest scores. Now, one common thing that people will do is that they'll say the range is 54 to 100. And that represents the range of values from least to greatest. But whenever I or the textbook or whatever the case may be, whenever someone is asking for the range, they are looking for one specific number. So give that difference number, the max minus the min. So again, don't do this to describe the range. Don't talk about the minimum up to the maximum. Take the difference. All right, IQR, we said that was Q3 minus Q1, the third and the first quartile. And here's Q3 and here's Q1. So the third quartile is 90.5, the first quartile is 70.5. So the difference between 90.5 minus 70.5 gives us an IQR of, and again, just like the range, I want that specific value, that specific difference. So the middle 50% of test scores, there's a spread of 20%. Now back to standard deviation. This is where we're going to have to press the up arrow key to go back to standard deviation. It was up there by the mean. And we're going to use this SX for standard deviation. And the X is just because it's kind of the go-to variable, if you will. But S is typically what we would call our standard deviation. It's really our sample standard deviation. So in our calculator, it calls it S sub X, or you could just call it S, either way. And that specific value, I didn't see what it was off the top of my head here, and I'm going to go 2 decimal places here, so 13.13. 13, I don't want that to look like a decimal though. 13.13, perfect. So the average amount that these values, all 20 of these values, differ from the mean of 79.8, on average, they deviate by about 13 percentage points. So you'll notice here, these spread values, they're kind of all over the place. We got a 13, we got a 20, we got a 46. How do we know which specific measure of spread to really discuss in any given problem? And again, that is something we will get more in-depth into later on. So there's how you can easily get the mean, X bar, the median, you can call that capital M, the standard deviation, S or S sub X, the range, and the IQR we got from taking max minus min, and Q3 minus Q1. So what I want you guys to try to end out the video here is, here's a new set of data, and again, it's 20 values. These represent SAT scores. And I want you guys to figure out what is the mean SAT score, the median, the standard deviation, the range, and the IQR for this data set. And again, if you wanted to go back to your calculator, you could simply go Stat, Edit, and if you just wanted to come over here to List 2, you could, but you could also go back up to List 1, go back up to the top where L1 is highlighted, press Clear, and Enter, and now you can enter in all your SAT scores if you like. So again, I'll check this the next day in class, and we'll talk about what these 5 values are. And that's all for video 2.